Okay, for this tutorial, we're just going to go over the relationship between subscripts in a chemical formula and moles. So the subscripts in a formula state give us the relationship of atoms in the formula and also tell us the moles of each element in 1 mole of the compound. So not only are they going to give us the atoms, but they can also tell us how many moles in the compound. So again, remember that this is, for glucose. These numbers did not convert correctly in this program, so we have C6H12O6 would be our formula. So for C6, we can say we have 6 atoms of carbon in 1 molecule. And we can also say we have 6 moles of carbon in 1 mole. Okay? So we can, for conversion factor, we would say we have 6 atoms of carbon in 1 molecule of C6H12O6, right? Or we can say we have 6 moles of carbon in 1 mole of C6H12O6. All right, so those are the 2 conversion factors. And we can do the same for atoms and moles of oxygen. And again, these can be flipped, right? We can flip it to 1 molecule. We can put this on top and this on the bottom. So as long as we're using these equalities, we can flip them depending on what we're solving for. So let's then look at a problem here. Oops, this is not the problem. So here's a problem. It says how many oxygen atoms are in 0.15 moles of aspirin? And let me get this. That's okay. So the step 1 is determining the given number of moles. And with any, problems that you do in chemistry, we always start with what we're given. And so this is our given, 0.15 moles of aspirin. So we know that our given 0.15 moles of aspirin, and we're going to write out the formula for that. Okay? Now it says write a plan to convert moles to atoms or molecules. And so we know we're looking for oxygen atoms, right? And so we need to go from mole